The following video will teach you how to find a vector between 2 points. So let's look at our first problem. I need to find a vector A to B given that point A is 2, 3 and point B is 4, 7. So if I have on a Cartesian grid, if I have point 2, 3, this is A. We have point B, which is at 4 over and 1, 2, 3, 4, 5, 6, 7. This point here, this is B. I need to find this vector from A to B. So this vector, if you remember vectors, vectors have a direction and a magnitude. The magnitude is the size. The direction is 2 to the right and 4 up. 2 to the right and 4 up. Now there's another way we can do this. This is geometric. We can show how to do this algebraically when we're given 2 points by subtracting the tail from the head. So head minus tail. So we're going to take the head, which is B, that's 4, 7, and we're going to subtract A, which is 2, 3, to get our new vector of 4 minus 2, that's 2, and 7 minus 3, that's going to be 4. We're getting the same vector that we had before. All right, so the next one we're still trying to find this vector from A to B. So B is the head, so 1, 4, minus the tail, which is negative 2, 7. Negative is a positive. I have 1 plus 2, which is going to give me 3, and 4 minus 7, that's going to give me negative 3. So this is my resultant vector. All right, again, we're still doing vector A to B. B is the head of the vector, so 6, negative 1. And I'm going to subtract that from point A, which is at 0, 4. That gives me 6 minus 0, which is 6. And negative 1 minus 4, that is negative 5. This is my resultant vector. One more. We're going to take our vector, our point B, which is 0, 0, and we're going to subtract our point A, which is at negative 1, negative 3. 0 minus negative 1 is going to give us 1, and 0 minus negative 3 is going to give us 3. So there you go. All right, moving on, let's look at number 2. I'm going to do 2 in 2 different ways. It says here, consider the point A. We have point A is at 1, 4, and I want to find the coordinates of B. All right, so I already have this vector from A to B, and that vector is 3, negative 2. So I know that head minus tail, the head of the vector is B, so I have some x, y value, and I'm going to subtract our point A, which is 1, 4, and that should equal 3, negative 2. So what is this x value that will give me 3 over here? Well, that would be 4. So we have 4, and what would the y value be so that we get negative 2? That would have to be 2. So we have 2. We could just do proper algebra to isolate our variable to get this, we're looking for a coordinate. So let's not write this like a vector. Let's write it as a coordinates of 4, 2. Now I'm going to show a second way to do this. So let's plot some points using our Cartesian grid. We have point A, which is 1 over and 2, 4, 4 up. This is point A. Point B is what we don't know, but we do know that we have a vector. We have this vector of 3 to the right, 1, 2, 3, and 2 down, 1, 2. So we have this new vector right here to find, and that new vector is pointing right to B, so our B value is going to be right here. So this particular point we can see is 1, 2, 3, 4 over, and 2 up. This point here is 4 over, 2 up, which is what we found before. But we could also take this point A, and add this vector to it. We can take this point A and add this vector to it to get to this other point. In fact, I think this is easier. We're going to take this point A of 1, 4, and we're going to add this other vector to it of 3, negative 2 to it to get 1 plus 3, which is 4, and 4 minus 2, which is 2. I think that's an easier way to do it. Of course, we're going to write this again as a coordinates, not as a vector. So here we have what looks like we have a C. It says C. I want to find C given that we have this vector C to A. So I don't know what C is. We could do it this way, or we could take our A value. We're going the opposite direction, aren't we? So we wouldn't be able to just add this to we can't just add this to our A point because we're ending at the wrong point. But we could subtract it, right? We could, since we're going in the wrong direction, we could always subtract it. So I have 1, 4, and we're going to subtract this value. So negative 1, and then minus 2. That's going to give us 1 plus 1, which is 2, and 4 minus 2, which is going to give me 2. I have 2, 2. Well, as a coordinates, this would be 2, 2 like this. Now, we could, I'll try to explain this the other way just to make sure that we did it right. It's always helpful to do things 2 different ways to make sure that we did it right. So we have this, we have some point A. We already know what point A is. A is at 1, 4. So we have 1 over and 4 up. This is A. And then we have some vector of C to A, which is going to be 1 to the left and 2 up. So that is this vector here. Remember, vectors, location doesn't matter. So this is vector negative 1, 2. This is vector negative 1, 2. This is vector negative 1, 2. So, but I'm trying to find a coordinates where I'm going to go from C to A. So we're looking at this. We're looking at this as our point right here. So you can see by inspection that this particular point is 2, 2. Oops, so we're still getting the same answer, 2, 2, right? All right, the head of our vector is at A, and so C has to be then right here. So all I did is I subtracted it because I saw that the vector was going in the opposite direction. Now if we look at 3, it says here that we have a diameter from P to Q, and this is some circle with center of C, and I want to find the vector from P to C. So we're going to do what we said before. We're just going to take head minus tail. The head is 1, 2, and we're going to subtract it from negative 1, 1, and that's going to give us 1 plus 1, which is 2, and 2 minus 1, which is going to be 1. So our new vector is 2, 1. This vector here of P to C is 2, 1. And then it says, hence find the coordinates of Q. Well, if I already know that this vector here it's 2 to the right and 1 up, then I can take this vector and move it to C and add it to this point. So I would have point 1, I have point 1, 2, and I'm going to add it to our new vector here of 2, 1. So plus 2, 1 to get 3, 3. So this particular point right here, Q, has to be at coordinates 3, 3. All right, moving on. We do the number 4 the same way. I have this vector here from, it doesn't matter which way. I'm going to use this vector right here. Vector, well, it says here find vector A to B. So I'm going to find this vector here. Vector from A to B. So head minus tail. So we have 6, 5. We're going to subtract 1, 4 to get 5, 5, 1 as our new vector. And then it says find vector C to D. Vector C to D, we want to find this vector right here. Well, that vector is just the inverse of this vector. So since vector A to B is this vector, and vector C to D is the same vector in the opposite direction, then I'm just going to reverse this vector out. I have negative of this vector, or negative 5, negative 1. And then it says, hence find the coordinates of D. So I'm going to take this point here of C, which is at 4, negative 1, and I'm going to add it to this new vector that points to D. So I'm going to add negative 5 and negative 1 to get 4 plus negative 5, that gives me negative 1, and negative 1 plus negative 1 is going to give me negative 2. So that's my, well, we're looking at a coordinates, not a vector, so this would be negative 1, comma, negative 2. So there we go. All right, I don't want to spend too much time, so we're going to, well, yeah, I don't really want to do everything, so I think I'm just going to skip to 6. It says find vector a to b, so we're trying to find this vector here. And we have the point, so it's just head minus tail. So I actually think this is stuff that we've already done before, so I'm not really sure that it's really advisable to continue doing this, especially since my video is getting a little bit long. Let's move down to 7. It says given that we have this vector b to a, and then we have another vector from b to c, which is negative 3, 1, and then it says to find our vector from a to c. So we can think of these, we can move these vectors to the origin. I think this is a really helpful way of looking at it. Move these two vectors to the origin. So I have a vector 2, negative 3. So 2, negative 3 is this vector here of BA. So this would be point B, and this is point A. And then we have another vector from B to C, which is negative 3, 1, 2, 3, and 1 up. So this would be C. And I want to find this other vector that goes from A to C. So I'm trying to find this new vector right here from A to C. So we could just count over and calculate this geometrically. 1, 2, 3, 4, 5 over, so negative 5, and 1, 2, 3, 4 up, so 4. So there's our new vector here of negative 5, 4. We have negative 5, 4. Now, can we calculate this in a different way? Is it possible to calculate this in a different way? Well, if you look at this, the way that I constructed, if I move all the tails to the origin, then this vector here of negative 3, 1, I can think of it as a coordinates. I can think of this as just a coordinates of negative 3, 1. And I can also think of this other vector here, if I move the tail to the origin, I can think of this new other vector here as a coordinates of 2, negative 3. So if they're coordinates, then we can just take head minus tail. So head of 3, negative 3, 1 minus tail of 2, negative 3, so 2, negative 3. And that's going to give us negative 3 minus 2 gives us negative 5. And 1 minus negative 3 is going to give us a positive 4. So there we go. We have negative 5, 4, which is our new vector of A to C. So I think that the video has gone a little bit long, so I'm going to end it here. I hope this video was helpful.